Hello, John here, and this is the 9th video in the CIDOS development video series. And in this video we are adding and testing the kill command, the help command and the about command. Well, in fact I've missed two. We're actually testing the lock unlock, kill, help and about commands. That's better. Right, the two we're going to be talking about the most is the lock and unlock, because those two commands are pretty complicated, because we're having to mess around with the inner mechanics of the directory subsystem. And what I mean by that is, in fact I'll show you. So the directory structure, right? So most of you should know that the directory is stored on track 18 of the floppy disks, from sector 0 to sector 20. I'm just checking my book just to make sure I get it right. So track 18 is 19 sectors. So the directory is on track 18 and there's 19 sectors in that track. And each sector can hold let's get this right, each directory block can hold up to 8 file entries. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And so a directory block is structured in this manner. So this one line is classed as a directory block, and what it is, the first 2 bytes in the directory block are the track and sector to the next directory block, and then after that there are 32 bytes in each of the file entries. And when you get a directory, it goes, right, there's the next track and sector, right, I'll run through these files, then it comes to this track and sector and then says, oh right, this is track and sector of the next directory block, the next directory block, and then if it comes to 0 and FF, that means it knows there are no more directory blocks. And so in this example we have got 8, 16, 32 file names in this directory structure on this disk. Now, but that's only just showing you the directory block. Then you've got the directory file entries, and each of these directory file entries are 32 bytes in length. And so the first byte of the 32 bytes is the file type, and that can be 0, 1, 2, 3, 4. So 0 means it's deleted, 1 is a sequential file, 2 is a program file, 3 is a user file, and 4 is a relative file. Then the next 2 blocks are the track and sector of that file, where the first block of that file. And then we've got 16 bytes after that, which would contain the file name, and that file name would have been padded out with spaces. The next 2 bytes are only used for relative file types, and that is the track and sector of the first record in that file. Not the first block that it's using, but the first record. And the next byte is basically just for relative file types as well, and it's just telling it what the record length of that relative file type. Then the next 3 pairings are track and sector information that the disk system requires, and then the last pairing is the number of blocks for this file. So the byte we're interested in is this one. We're going to modify this byte, the very first byte in the file entry structure. And the reason why I'm saying we're having to edit that one is because the file type has many different states, right? So the first byte is, of course, it's going to be 8 bits. No, 7 bits. No, 1, 2, 3, 4, 5, 6. Yeah. So that's bit 6 and bit 7. Me getting a little bit carried away with me diagramming. Right, let me see if I can get rid of that column. There we go. It's better. Right, there we go. And so the first 3 bits, or the least significant, the 3 least significant bits, identifies what the file type is. And then we've got 3 middle bits that are at the moment not used, that I know of, and then the last 2 bits are to indicate whether it's opened or closed. So if it was closed, it would be a 1. If it's opened, it would have been a 0. Yeah. And bit 6 tells the disk system that it's protected or not. And so what we need to do is we need to be able to modify bit 6 on the file type byte. Right? So to set it, so to set bit 6, we need to OR it with 64. Yeah, because you want to set bit 6, so you need to OR it with 64. But to clear bit 6, we need to AND it with 256 minus 64. 255 minus 64 is 191. Alright, so we're basically going to OR it with that bit structure, or we're going to AND it with that bit structure. And so that is the rule set we need to do for bits. So when we've identified that byte in the directory RAM on the disk, we need to either set it by doing an OR with 64, or clear it if we're doing an unlock and to clear it we need to do an AND with 191. Alright, so keep that in mind. So here we go, here's the code. So what we're going to do is going to look at the lock and unlock. So here's the lock command, and what we're doing, we're putting L into the lock command byte and then processing the lock unlock in command, and as you can guess, the unlock will be U. So this is the important bit here. So if we go to the lock routines, which is here, and we start from here, and what we're doing is we're clearing out the file name, we're getting the file name. Yep, so this is getting the file name we want to lock or unlock, and then we troll through the directory. So we start at track 18 sector 1, and then we open all the file numbers for the unlock system. So there's going to be 2 file numbers, I think. One's going to tell the disk what to do, and the other one's going to read what the disk gives us back. So we load the current track number and sector number, which we set to 18.1, and then we send it to the disk and say, can you read this sector for us? And then what we need to do then, because it reads that sector into the disk command, then we need to tell the disk to point to byte 0. in the RAM, in its RAM. So we want to get the next character. Now if you remember, the first thing it is the directory block. So the first character, well, the first two characters is the track number and the sector number of the next directory block. Then we set the file name in the so we now know where we are, so we're setting the file name in the structure, so we're initializing it, and we're saying get the point into the next file location. So we're getting the information for the next file location. Then we're getting, as I've called it, the file protection status, which is actually the file type. So this is the byte that we're really interested in. This is the routine that gets our byte for us, and so we store it away. But then we have to get the track and sector for that file, and then we have to troll through the file name and store it, and then compare it with the file name that we've got, which is all this lot here. So we get it, we store in FF in have we found the file, yeah, and then we run through each character and we compare it with our file name, and if it's equal, it goes to the next character, which is here. Increases, goes back round, carries on. If it's not equal, we set our found file name to 0, which means false. Yeah, and then we just carry on through the file name. If once we've identified it, it's not the same one, we still have to read those bytes because they're in the disk memory. If it is the same, we carry on going, and then after the 16 bytes we come here and say, right, did we find it? Did that status get changed? No, it didn't. Right, so we need to test the next file number. Yeah, so it's not the same, so you need to test it. If it is the same, then we can actually process that file name. So what we do is, if we jump to process protection of file name, here we go, we point to the next file location, we find what command we're running. If it's U, then we AND it with 191, the file protection status, and then we commit it back to the memory in the disk drive. So we tell the disk drive to load that sector into memory, and then we change the memory, and then what we do when we're finished, when we commit, we tell the drive to take that memory that it's got in it, take that data that it's got in its memory and save it back onto the disk. So we're not actually changing the data on the disk, we load the sector into memory, we modify the memory for that sector, and then tell the disk to commit that sector back to disk. And that's what it's doing here. So it's loading the current sector, and then we tell it to go and update it. Right? And if it is to lock it, then or it's 64, and then we go through this again, and then we print out whether we know that it's locked or unlocked. Yeah, so the file has been locked, the file has been unlocked. So we're setting up two files. This is an outbound file number, and this is the inbound file number, and then we've got the text to do the read and write. So U1 is reading, I think, and U2 is writing, and we have to tell it which track number, which sector number, and where we want to put it, and the byte number as well. And this is the routine to run that. So this is the routine to run through each byte pointer in the disk drive's memory. So here is to read the track and sector into memory, or write the memory to a track and sector, and this one is to, once it's read it into memory, is to run through that memory from the C64. So we're telling the disk drive, go to this memory pointer in your memory, and then to close the files. Now I can't run this in emulator mode because the emulator doesn't, I could set it, we can set it, I can show you it setting, but I don't want to scratch it because it ignores the the file, the file protection status. So if I go into CIDOS and unram lock and unlock, and then go to the tokenizer and activate the commands. So lock, unlock, lock, unlock. Right, so here we go. Oh, we've got an error. What's the error? Must specify start address. Plank. Keep doing that, keep forgetting. Here we go. Alright, so that's why 64738, activate CIDOS. There you go. So we're going to attach disk image. So there's our test image. So catalog, there's nothing on it, right? 10, print, John, 20, print is 30, print, great, 40, end. So we're going to save this as JCD test, (8). In fact, we don't have to. Let's use the commands that we've chain John test. There we go. So catalog again. There's John test. So now we can lock John test. So it's now been locked. So if we do a catalog, there you go. Can you see? He's put a less than sign against PRG, and that's because we've set the file type byte for that entry. So if we do chain JCD test2 catalog, see, the other one hasn't got it, so we could lock that as well. JCD test2 catalog, there you go, and unlock JCD test2. So that's been unlocked, catalog, there you go, and the less than has disappeared. Alright, so that's lock and unlock, and that is where we're talking directly to the disk drive, not to load a file, but telling the disk drive, load that bit of disk into your memory. We're going to manipulate that memory in your manipulate that data in your memory, and then tell the disk to store the data it's got in that memory back to the tracking sector where it got it from. Now the other three commands, which is kill, about and help, they're pretty easy. So we'll load them up and we'll load the tokenizer and we'll activate them here, right? Because what kill does is it undoes the initialization of the cartridge. So the initialization of the cartridge is up here, yeah? So it's looking for the, if we go to initiate, it's looking for these here. So what we're kill just deletes part of it, so it doesn't recognize it anymore, right? So we'll get rid of the tokenizer. Now we've changed it. We've done change directory, don't need that. Done lock, done unlock, done macros, don't need that. Done the lock unlock routine. So kill. So what it does, it loads 0 and it stores it in 8004. Now the problem here with that is we need to test for the VIC and the 64. Right? So we need to test So that's the Vic, and if, and we'll do it for the 64. So this is the 64 code. And if, and what we need to do here is it's STA $A1004. So if it's a VIC, it's 8004, and for the 64, it's 8004, and it just destroys that CBM 80. Yeah. So when the computer restarts, it looks for the CBM 80 for the 64, CBM 80 for the VIC, can't find it, so it just goes back to normal. For the help, we're just loading this text and displaying it, dead easy, just literally that. And same with the about, is almost exactly the same. In fact, it is exactly the same. So let's just go straight into this and build it. And I've done the same thing again. Wrong program. There we go. Yeah. SY64738. There we go. So help. Now something wrong there. We've only got up to rename about, and it doesn't like about. Now what have I forgotten? Bet you have forgotten in the tokenizer. Did I activate the commands? Yeah. Help, about. So this is the about. It's jump ready, isn't it? Jump ready. I think that was it. So the help test, why did it stop after collect? Because that should stop. Ah. Right. Try that again. I've got a sneaky suspicion that the routine I've picked can only do up to 255 characters. Sneaky suspicion. So help about. The about one still doesn't like the about. Okay, so we need to write a routine to do the print. Hang on. So let's think. Right. So what I've done is I've created my own AB1E routine, which is here. So what we're going to do is routines, character out, it's there. What we're going to do is we change the about to come to our routine, as in the one that I've just created that goes, and this help text as well. So let's see if it does it now. It should do. I don't know why about was failing, so it'd be interesting to see why about was failing. So let's see, let's start it up. 64738 help. It's better. About. That's better. There you go. So it's just February. Oh, I can't spell February. Oh, have I spelled it right? So this is basically. So if I help again. There you go. So there are all the commands. I think they're all in there. Switch, erase, mount, dismount, root directory, catalog, initialize, copy. So kill. So this is where we kill the routine. There you go. So SY64738 will not bring it back, or even escape, restore. See, it's gone. So we have to reload it back in if you want to use it. So there we go. This is 64738. There we go. Catalog. So device. Great. We've done lock, help, yeah. So this is, I think this is the end of the video series, and so all this code is going to be on my GitHub for you guys to mess around with, to modify, make better, add commands. There's plenty of space left between 8,000 and 910 to 8,000. Yeah, because it's all RAM up to there. So we got, there's plenty of space. I don't think this even crashes through the 9,000 mark yet. Let's have a look. Let's just build it again. I don't think it's 4K yet. So let's scroll straight to the bottom and we get 8dBF, and that's with all the text in it as well. So 2,116 lines. Wow. So this code's going to be in my GitHub, and you guys will be able to grab it and mess around with it, learn from it, and hopefully you should be able to make a cartridge from it. We'd have to modify it slightly because we're assuming that we're not a cartridge, that we're a program. So we'd have to, all the variables that we've got, we'd have to move to areas outside of the cartridge range, because if you do it within the cartridge range it becomes read-only memory and you can't change it. But I hope that you guys learn from this code, and any questions please direct them to me in the comment section. And so with that, that's the end of this video series. Well, unless I figure some more commands out, we might get some more if I put some more commands in. But this was basically what I did with the TDSOS, but now it's called CIDOS, and it's for you guys and out there. All the source will be out there for you guys. So with that, I will say goodbye, and I will see you in the next video. Take care everybody. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.